All right, so this is Excel 9A. First of all, I'll save my work. I'll go save as, save it in the file where I always save my work. Change the file name to Chew. Put it in the folder. All right. Cannot check over because the name was as another open workbook or there is something else. Choose a different name. Okay. I will just put 2 right now. All right, so my file is saved on my computer. Now, in this project, we have to use some financial functions. Make sure your name appears on the first page, and this should be correct. You should save the file and then move on to the loan payment worksheet. In this one, we have to use some financial Excel tools. So we are analyzing a financial data for a nursing hospital. We have to first of all fix some errors. So go to the loan payments worksheet. The hospital needs a loan to buy the medical van for a neighborhood nursing program. Before Pranjali can calculate the principal and interest payments on the loan, she asks you to correct the errors in the worksheet. Correct the errors as follows. So the first step we have to find errors and fix the errors. One way is to go to the formula tab, search for error or look for error checking. Then click on error checking. Once I click on error checking, it actually shows me all the errors on this worksheet. So the first one it has picked on is actually 817, which is the cell which they're talking about. Now we have found there's an error in 817. The second step is to fix this error. Also, if there is always an error, you will see a small green color on the corner, and you may see something like this value or name error. So here we have to fix the error. We have to calculate the total, the values in the range C17, G17. This option of error checking, it gives us actually a lot of options. First of all, it can show us more help. We can click here. This will open a new page on the browser, and you can read more about this error. And it also tells us what is the value in the cell, what type of error it is. The formula contains unrecognized text. Now, it just tells us there's something which Excel don't know what it is, what it means. We can show calculations. If this formula points out to some other cells, it will actually show us. We can ignore the error. If we ignore it, then this green checkbox will go away, and this would be a normal cell, but error will remain there. It's just simply like if you have a spelling error in Word and you say ignore, so it will ignore that spelling error. We can fix this by clicking here. We can fix it here, or we can click here. So once we click here, it takes us to this area. Here, we have to make sure that it does total for this range. How can it do total? We can just simply use sum function. And it sums C17 and G17, so which is correct. So once I press OK, resume back, my error is gone. So this is fixed. You will calculate the interest and principal in the range C17, C18 to remove the remaining errors. So remaining errors are these ones. There are so many more. So click one by one. What we can do, we can actually click. Now this is fixed. This is almost done. This step is done. We just fixed here, put the sum function, and this is fixed. Now there are more errors here in each of these cells. We can fix this. The tool they want us to use, or the method they want us to use, is the trace precedent arrows. So I will go to the cell on cell C20 and go to my formulas tab and then click trace precedence. once I click trace precedence, it shows me where does this value comes from. And if I click on error checking on this cell, it actually shows me the problem. If I just look at the cell, it seems pretty fine. C19 divided by D4. Error in the value. Why there's an error in the value? It tells us a value used in the formula is on the wrong data type. So they're saying you're using something in the formula which is wrong data type. For example, you're dividing by D4. Now D4 is a text, so it cannot divide by a number. It means it is a wrong data type. And we only figured this out by showing the precedence. By showing these arrows, we can actually, okay, so this cell actually points out to this cell and this cell. So it points out to two cells, this cell and this cell. So how can we fix it? We found the source in the error, and the source actually comes from D4. Correct the formula in cell C20, which should divide the remaining principal cell C19 by the loan amount D5. So we can simply fix this by dividing C19 by C5. Once I hit enter, the error is fixed. Same thing, we have to do fill in the range D20 with the formula in cell C20. We have to apply the same thing over this range. We can also look at here trace precedent. It again says this cell and this cell. It points out to two different cells. D20 to C20 using the formula in C20. And this one, so this one, this one, this one, they all point to the wrong formula. If I just click on, if I just copy this, it will actually fix all of these. So these all are fixed. Remove any tracing errors. We don't have any. It's all fixed. G20 is fixed. So all of this step is done. Now Pranjali is ready to calculate the annual principal and interest payments for the medical van. Start by calculating the cumulative interest payment as follows. So first let's go to C17 and see what is being asked for. C17, enter a formula using cumulative IMPT interest payment. So it's asking for cumulative interest payment to calculate the cumulative interest payment on the loan for year 1, payment 1 in cell C15 through payment 12 in C16. So we can find interest payment, cumulative interest payments of a year of a loan for each year and how much it will be. So for example, we are trying to figure out what is, or we are just trying to figure out what should be the interest payment for the first year. What is the principal payment? So this person has a loan. If you look at here, this is the loan amount. This is the annual interest rate. This is the monthly interest rate. This is the period of 5 years. There are each payment made per month. So there are 60 payments and monthly payment is around 4,347. Loan starts on this date. Here we have to figure out what is the total amount of interest this person has given after 1 year, meaning 12 months. We can easily find this using IMPT function. The way is, what you have to do is actually simply start with the formula. Let's start with the formula and I'll just enter IMPT. The first thing is the interest rate. So let's go on to the interest rate. Now we should use payment in cell C1, C through C15, use 0 as the argument of payment. All right, so let's take the interest rate. We will always take the interest rate of per month. because the payments are made in months. I'll put a comma. Make sure I will make it absolute. Next thing is the N per. N per is the number of payments. N per is this cell. These are the total number of payments this person has to make. Okay. Again, I'll press F4 to make it absolute. Next argument, sorry. Next argument is PV, present value. What is the present value? Which would be the loan amount. At the year 1, the loan amount is actually the present value. I can also make this one absolute because these values are not going to change. Start period. They have given us the start period. Now, start period is year 1. Ending period, you can also say month 1, year 1, month 1. Ending period is actually 12 months. I will not make this absolute because I may apply this on other ranges. And the final 0, use 0 as the type of the type, use 0 as the type argument in your formula because payments are made at the end of the period. So in finance, you may know if you make a payment at the end of the period and the beginning of the period, it does make a difference. If you make a payment at the end of the period, you have to pay the interest. If you make at the beginning of the period, you don't pay interest on the first payment. So I'll put 0 just to show that payments are made at the end of the period. Press enter, you got your value. And they do tell us that rate and per PV argument are listed in the range D5 to D11. These are the values listed. Make sure you do absolute. And then next one, use relative references for the start and the end payment. Start and the end argument. We can do that because for C15, we didn't put anything for C15 and C16 because we want this to be changing over year to year. So on year 1 for 12 months payments, this person would be paying almost 6,000 in interest. Build the range D17, G17 using the formula in C17 to calculate the interest paid in years 2, 5, and the total interest. Let's see if I drag this. So for the year 1, this person paid 9,332. For year 2, it will be 7,000 something, and then 5,000, 3,000, 1,000. So over the period of 5 years, we add up all this interest and it comes down to here. We can, same way, we can actually calculate the principal amount paid in each payment. So how much principal amount would be paid? We can do this over here. Let's see what they want us to do. So our interest for each year has been figured out. Interest decreases over time. As you start, you are paying the highest interest because your outstanding amount is the highest. As you will move on from year 1 to year 2, your interest will actually go down, and the final year you are paying the least interest because most of the principal has been paid. So let's move on to cell C18. In cell C18, enter a formula using cumulative principal. So again, that was cumulative interest. Now this is cumulative principal. Again, we have to use the rate. Now the rate should be the monthly rate, not the yearly rate. I'll press absolute, put a comma, number of payments, the total number of payments, absolute, present value. This is the present value. Start period. I will just make sure I'll make this absolute. And And then start period is actually month number 1, and end period is actually month number 2. And of course, this one is also going to be the end of the payment, end of the period. So I'll put a 0 here and close it. So I got my principal amount. So on the first year, I paid 42,000 in principal, and my payment, my 4,000 per month payment, if I multiply by 12, I will get my total payment. And then out of that, there's 9,000 interest and 42,000 principal. I can apply this to the whole range. So one more time, I can just show you the formula. So it's D7, D9, D5, C5, C16, and 0. All right, let's move on. I think this is the same logic, same thing. We have just done it. And it does adds up here. If you add these two amounts, it actually is the total amount we have paid. This is the total amount. This is the total thing we have paid. We borrowed an interest of 234,000, and we paid on top of it 26,000 interest on it. We paid the principal and we paid the interest. Let's move on to the depreciation worksheet. Let's go into the depreciation worksheet. Pranjali needs to correct the errors on this worksheet before she can perform any depreciation calculations. Correct the errors as follows. Use trace dependent arrows to determine whether the hash value error in cell D12 is causing the other errors in the worksheet. So let's go to this D12. Where's D12? So this is D12. Let's see the trace precedent. All right, it tells us that I think that is the problem. I believe this is the problem. It's actually pointing out to this cell, and it's pointing out to this cell. And what it's doing is doing C12, which is this cell, add in C B12. B12 is a text. If we diagnose this error, we will find out that actually this is actually we find out that this is again an error within due to the wrong data type. So Excel is telling us this cannot be done. You cannot add a text value to a number. So if we fix this cell and apply to all other cells, actually it will be fixed. So let's fix it. How we can fix it? Use trace precedent error to find the source of the error in cell D12. We just did it. Correct the error so that the formula in cell D12 calculates the cumulative straight line depreciation of the medical van by adding the cumulative depreciation value in the year 1 of the annual depreciation value in year 2. Okay, interesting. Let's see. So it's coming from, it's actually, it's what they're trying to say here. They're just saying, correct the error so that the formula in cell D12. So this is our D12. Okay. And calculates the cumulative straight line depreciation. So it's a straight line depreciation. First year, we had a depreciation of 0. On the second year, we add this depreciation to C12, which is coming from here, the annual depreciation. So we take it cumulative 0 plus this one. How about instead of B11, we should fix this. How about we just do, we go to the cell D12, and then instead of, we should do D11. That will actually fix it. So once we fix it, it fixes everything. Why? Because these cells are right now empty. We have to fix this. We have to fill up the values here, but that can come later. At this stage, we are saying in the first year, what is the total cumulative? What is the total cumulative depreciation for the first year? It's actually zero because we don't have a value here. Okay. On the second year, we just say it's C11. It points out to this cell C11. On the second year, okay, on the second year, it points out this cell and this cell. So it points out two cells, if you think about it. It actually points out this cell goes here and then this cell goes here. So this shows us it adds this cumulative and this year's depreciation. We have to put depreciation here. In the third year, if I do trace precedent, it actually shows you take this value and you take this value, two values, and puts here. So once I fixed this one, actually all other are fixed because they're just depending on this one. They are not depending on something else. This was pointing out to a wrong cell. Once I fix this, all other are fixed. So the language is a little bit confusing, but actually it's straightforward work. So let's move on to the next step. In next step, Pranjali wants to compare straight line depreciation amounts with the declining balance depreciation amounts to determine which method is more favorable for the hospital's balance sheet. All right, so we want to compare straight line depreciation method. Now, it's a specific method to depreciate a value. You use salvage value and different life of the asset and the total cost of the asset, and you figure this out. Now, they're saying they want to compare depreciation with declining depreciation. So there are two types of depreciations. This is a straight line depreciation. This is a declining balance depreciation. I would say at this stage, you should not worry too much about these concepts. Just try to apply them. So first thing, in the range D5, D7, I will remove these arrows first of all. D5, D7, we have some values. We have some estimates. We have the long-term asset cost. We have salvage value. Salvage value is when everything is finished, the asset has lived his life. What is the salvage value? What is the remaining life? You may have heard this concept or this term for cars. Salvage value of a car. When the car has been totaled or totally destroyed, the remaining value is the salvage value. Neighborhood nurse program will have 232,000 the tangible assets at the startup. Okay, and the useful life of these assets is 7 years with a salvage value of 37,440 value. All right, so let's do it. Let's do step by step. Go to cell C1, C11, sorry. In cell C11, enter a formula using the SLN function. SLN function. This formula calculates straight line depreciation using long-term asset cost, salvage value, and the life of the asset. The first one is the cost, so we can simply point out to the cost. The second one is the salvage value. We can point out to the salvage value. The third one is the useful life. We have the useful life. I can close this. I can select all this and make it absolute because these values are just fixed. They're not going to move if I apply on the whole range. So on each year, the annual depreciation in a straight line method will be actually fixed. It will not change. So I can just copy this simply. And they must be saying this. Use the references and then fill the range D11 to I11 using the formula in cell C11 to calculate the annual and cumulative straight line in years 2 to 7. So it's just annual depreciation is just equal. Every year it just depreciates equally. That's why it's called straight line depreciation. But if you calculate the cumulative, which actually adds these two values, so it takes first year, it just takes this value, C11. It just points to C11. And then I will close this. And then in the second year, it takes this value and this value and shows us here. On the third year, it takes this one and this one. So it just accumulates. It's just cumulative. So I hope this is clear and this step is clear. Let's move on to the next step. The declining balance depreciation. So let's go to cell C18. Now for declining balance, the formula is DB, simply DB. We take cost, we take salvage value, we take the life, and we take the period. Okay, D5, D6, D7, and then we have to take the period. For period, I can just point out here. And the last argument is an optional argument. All right, so this one, what this one shows that I will make all of this absolute because these values are not going to change over year to year. In the first year, we have first year depreciation is saying it's 53,800, 53,820. But on the second year, it will actually pick in the last cell C17, it will become C18. So it will be declining balance depreciation. And once I apply this, it actually goes like this. All right. Actually, I think I did right. C17. Yeah, I think this looks correct. E17, F17. So one of the major differences is the value of the asset depreciated in the first year the most. In the next year, it depreciated less. And in the third year, it depreciated more or less. Over here, it's just constant. Here, it depreciates more in the beginning, and then it depreciates just very less in the end. All right, just give me one more second. All right, let's keep going on. All right, I'm just checking the sound system. Can you guys hear me? Okay, I hope you can. All right, so let's move on. I think this is done. This step is done. Let's move on to the next step, which is about Pranjali also wants to determine the depreciation balance for the first year and the last year of the useful life of the medical van. Determine these amounts as follows. In cell E22, let's go to E22. So the person wants to know yearly depreciation allowance for the first year and for the last year. So we can actually use a formula. There's a specific formula to do this. The formula is SYD. SYD takes again cost, salvage value, the life, and per. Per means payment number or per month or the month, you can just take it like this, period. You can just take it like this, period, and period. Period right now, they have said as for the first year, I can point to the cell C17, will actually do the job. I can also make this absolute, or I don't need it because I'm not going to copying this anywhere. In the next cell, how about I just, yeah, I just do it again, SYD. So now this is for the last year. This is for useful life, years of useful life of the asset. The cost, salvage value, life, and the period. Now this time, the period should be the I7. And close it, and it's done. It didn't work. Why is that? All right, it's fixed. All right, so this step is also done technically. Let's go on to the earnings projections worksheet. So let's go into the earning projections. So this worksheet has a lot of data and graphs. It shows us earning projections, earnings goals. The revenue goes up, down, up, down. It goes in cycles actually. So let's move on to earning projections worksheet. Pranjali has earned the most of the income in the expense data on the worksheet. She knows the income from the municipal grants will be 25,000 in 2020. So how about we fix this? All right. So what they want us to do is let's first try to understand what exactly they want us to do. Oh, maybe they want us to fit a line. Okay, so let's see. She knows that income from the municipal grants will be 25,000 in 2022 and estimates will be 40,000 in 2023. She need to calculate the income from the municipal grants in the year 2023, 2025. The grant should increase at the constant amount for the year to year. Project the income from the municipal grants for 2023, 2025, cell D15 or D5 to C5 using a linear trend interpolation. So let's try to do it. What actually they want us to do, if you click on this cell, it just shows us that this is coming from months in operations, okay? And then these values are actually coming from C1, B2. C1 is the whole table. B2 to B61. It's actually coming from B2, sorry, B2. I'm just trying to figure out, okay, where this data is coming from. B2 to B61. This whole thing, it's pretty long. Okay, this whole thing they have created. All right. And then this one, revenue projections, are C2 to C61. Actually, this whole column. This whole column all the way. All right. We have to fit a line here. We have to fit here a line. Let's go to chart design. And we are trying to fit a trend line. So let's go to trend line. Now, what kind of trend line do we need? Using a linear trend line. So let's try to put a linear trend line. It actually fits like this. Using a linear trend line, project the income from municipal grants for 2023, 2020 using cell D5 to D5 to F5. What is D5? I'm just trying to understand what is D5. This is D5 and F5. All right, these three cells. All right, so I think we have missed something. What we have missed here, she knows the income from the grants will be 25,000 2022 and estimates it will be 40,000. So I think this is the part we missed somewhere. She needs to calculate the income from municipal grants in the year 2023. The grant should increase as a constant number, constant amount from year to year. All right. Project the income. Okay. So I think there are multiple ways we can do it. We have to fill in these values. We have to project these numbers based on the graph, on the data. By fitting the data, we can actually project this. All right, so I think one thing what we are missing here is we have to fill out these values first and then maybe create this trend line. So first thing I'll do, I will actually remove this trend line. So instead of this trend line, which is here, you can either undo if that's your last step, or you can just click on the trend line because we haven't filled out these values. There was some important information here which we missed. So I will first remove this and then come back to it later. So I'll go here, I'll go to trend line and none. It's not gone. Let's do it again. Okay. I think it's gone now. Yeah. Now it's gone. So I'll close this area. So first thing we have to do, we have to fill out these values. Now it gives us these estimates or some information where it say for the first year, which is year 2022, they have 25,000. She knows that. For the last year, she knows she has an estimate of 40,000. And now she tells us that the growth or the increase from year to year is actually pretty constant. And there's a projection from other years for 23, 24, 25. It's actually linear, meaning it's just increasing at a constant pace. It's increasing, but it's increasing at a constant pace. We can fill out all these missing cells or interpolate the values by selecting the range, going to the series option. Actually, this is called the fill option, fill, and then series. Once we are in here, we have to make sure we are on the row because we are trying to fill up the row. And then linear is completely fine. Step value, Excel has already found the step value is almost 3,749 as a step value. So it will add 3,049 in this one, and then it will again add 3,000 some 49 value in this value, and it will end up at 40,000. So once you press OK, it will actually fill out all these values. So this was a step which we missed, and I just created quickly a trend line, but that wasn't the step. That's not the wrong thing. That's not the right thing. So make sure you do this and then go on. Next step, which is about calculating the income from insurance reimbursement in the years 23, 25. She knows that the starting amount has estimated amount is 2026 and 2026. She thinks this income will increase by a constant percentage. Project the income from insurance for this cell. So we have to again, so what the bottom line is, she has an insurance reimbursement for the first year and she has an estimate for the later year 2026. Now we have to fill this area using based on this information. And let's click here. Instead of linear, we will this time hit growth. So there's a growth. It's increasing at a certain value. And the step value figured out by Excel is actually 51,000. Press enter. So all these values actually don't appear, but they are there. Maybe let's do it again. I feel like this is not correct. I have this feeling once I click here, once I go here, series, I think this is not correct. Maybe I have to hit this. Oh, yes. I may have to hit this first and then run it. This is the correct value. So make sure you hit the trend button because they're talking about growth and there's a trend in the growth. So make sure you hit the trend once you have selected the data. So I'll just show you one more time. I'll select this data, go here, series. I will make sure it's growth, but it's not just a growth based on some value. It's actually based on a trend. And Excel will find its own trend. Press OK, and then it creates a value. So this is the correct way of doing this step. Pranjali needs to calculate the payroll expenses in the year 2023-20. She knows the payroll will be 1,40,000 in 2020 and will increase by at least 5% per year. Project the payroll expenses as follows. So now this is also a growth and a trend. Project the expenses for payroll for 2023-2020 in cell D13, G13. So this is our cell. Am I right? Yeah. Using a growth trend extrapolation. Using 1.05 as a 5% increase as step value. So let's go back here. Let's do series. Let's do growth. And this time I have a step value. So I will use that step value, 1.05. Press OK. And it produces value. What it does, it actually creates 5% increase. It does a 5% increase every time. And every time in the previous value. And that's a growth. That's another way or another method to do projections in Excel. All right, let's move on to the projected revenue line chart, which is actually, let me see, which one is it? I think it's this one. In cell H4 and Q19. H4, Q19. All right, shows the revenue Pranjali estimation in 2026. She wants to extend the projections to 2027. Modify the projected revenue line chart as follows to forecast the future trend. So right now it's 2026. The chart ends at 2026. We want to add one more line. And then we have to add one more period trend line. All right. So I think what we have to do, we have to just click on this chart maybe, and then go to chart design, go to trend line, chart design, and then go linear. And then in linear, probably we should just do a forward linear with one step. How can I do it? I'll click here. This is my trend line. How did I get this trend line? I clicked on chart design, went here, went to trend line, select linear. And once I have the trend line, I will go to its options. Now these are the options of trend line. Here in the forward, I'll put one period forward. So at least it will show me one period forward. Once I do it, it actually shows me a trend line one period forward. The data is until just here, 2026, but the trend line is here. It tells us that actually in 2027, we will have almost 700,000 of revenue. Moving on to the next step, step number 13, revenue trend scatter chart in the range A21 G40 is based on monthly revenue estimates listed on the monthly revenue projections worksheets. So let's move on to the next worksheet. All right, it's a monthly revenue projection for each month. Okay, I can close this one. Pranjali wants to include a trend line for this chart that shows how revenue increases quickly at first and then levels off in a later months. Modify the revenue trend scatter chart as follows. Include a logistic trend line. I think I went to the wrong worksheet. We don't have to go to this worksheet. Actually, this chart is based on this worksheet. Yeah. So let's see. So this whole data probably produces this chart because revenue monthly projections is actually this worksheet. So this chart is produced using this data. And that's what I was thinking. How come there is some hidden data or there's some data which I cannot really see, but it creates all these charts? So this is our chart and this is the data. This chart is based on this data. What we have to do here, we have to just add a trend line. And the trend line should be logarithmic. How about I do more trend line options and then click logarithmic? Yeah, this is correct. So I just did both steps together. So we can go here, add the trend line. You can add the trend line and then fix it, or you can just go trend line options and hit logarithmic. It will create this kind of a curve. Like it starts below, it goes up, 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 and then it levels. Go to investments worksheet. Yeah, so this worksheet we don't really use because we have the chart. So let's go on to the last worksheet, investments worksheet. The worksheet shown in the returns potential. Okay, what does that mean? Okay, this worksheet should show the returns potential investor could realize if they invested 165,000 in the neighborhood nurse program. Pranjali figures a desirable rate of return would be 7.3%. She estimates the investment would pay the different amount each year. Range C7, C12, and wants to calculate the present value of the investment. Calculate the present value of the investment as follows. So technically what we have to do, we have the payments, startup payment, and then each year payments, and it shows this is our total payment we will get in 6 years. This is the total cash flow coming into the company in 6 years. How about what is the present value of that amount? We can find that. We can find the total present value of that amount. Go to cell C15, use NPV function. NPV function takes at least 2 inputs. All right. So in NPV function, we will put 2 inputs and solve the problem. Oops. What did I press? So let's do it. NPV function rate. Rate is the first thing. We have to use the desired rate of return in cell C14. So where's C14? This is our interest rate, comma, and use the payments in years 1 to 6, range C7, C12. These are the payments we are going to get. As the rates pays to the investor in different omits of adjacent cell error warning appears, ignore it. I didn't get any warning, so I think I'm fine. C7, C21, or C12. Yeah, this formula looks correct. So this will calculate what's the present value. So the logic here is that this person is investing in a startup. Okay. This person has given 165,000 to a startup. On year one, they will get 25,000. On year two, they will get 30,000. Year three in this one. Now, if the person expects 7% rate annually, and they think if I just don't invest in there and someone else can give me just 7% yearly, then what is the present value of my total payments? Because I will get all this year over year. So actually the present value is 166,000. So they have invested 165,000. The present value is 166,000 with 7% interest rate. Let's move on. There is an error. Actually, there is an error. We can actually ignore this error. Ignore error. Ignore. So I did ignore an error. Yeah. Pranjali also wants to calculate the internal rate of return on the investment. If it is 7% or higher, she is confident she can attract investor. What is the internal rate of return? That's IRR. So those who are in finance, they may understand this pretty well. IRR. So these things in finance, this is everyday life. This is you may not have to worry about if you're not in finance. You can just figure out how to enter formulas at this stage. My job is not to teach you the financial concepts here, and that's not the goal right now. The goal is if you take a finance course, it becomes easier for you as compared to other people because you have done this on Excel before. So let's do IRR values. First thing is values. For the IRR, you just enter the values. We have to actually enter this one too. For IRR, I'll just do this. For IRR, you can start from the startup cost and then add all the values. And this will actually give me the interest rate. How much should be the interest rate I should offer to investors? This is 7.5%. That would be attractive to them. All right, so you can just save your work and then you can submit your work. I think I have a name issue, so let me just fix the name issue. All right, so you guys can submit this work and see how it goes. I think it will be all set. We can also look at these values. They should actually match. Yep. 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 So they all match. All right, so this is pretty much it for number 9. I hope you guys will be able to do it A and B through this one. I'm very sorry I couldn't come on Tuesday because I was really sick and I don't want to come and make other people sick. All right, thank you so much.